If you built a skyscraper on shifting mud, it would collapse in seconds. Yet across the United States, 40-ton freight trucks barrel down highways at 70 miles per hour over that exact same ground, hauling cargo worth billions without cracking the surface beneath. American engineers didn't just pave roads, they forged horizontal fortresses of steel and stone, compacting foundations as firmly as high-rise towers, positioning reinforcements with centimeter-level precision, and deploying massive automated machines to lay seamless slabs engineered to carry extraordinary loads for 40 to 50 years. But permanence means battling a material that generates its own heat as it cures, expands, and contracts like a breathing lung with every temperature shift, and can shatter from a single degree of miscalculation in the chemical reaction that turns liquid slurry into solid stone. So how do American engineers turn raw materials into highways that function as buried skyscrapers built to last half a century? Join man-made marvels as we go inside the hidden engineering of roads designed to survive millions of vehicles and decades of punishment. The battle begins long before the first shovel breaks ground. Engineers drill core samples to measure load-bearing strength and identify weak zones where clay or sand could betray the road decades later. Once the plan is locked in, the construction army mobilizes. Bulldozers tear through vegetation, stripping the land to raw earth. Graders follow behind, sculpting the roadbed with GPS-guided precision that won't tolerate a centimeter of deviation. Beneath the surface, crews install drainage pipes to channel water away before it weakens the foundation, plus the electrical conduits and utility lines that must be buried now or never. For roads without curbs, workers carve ditches along both edges to swallow rainwater. The soil itself must be tamed, compressed, transformed from loose earth into something capable of supporting thousands of tons. The ground trembles as 20-ton steel drums roll in, shaking the earth with bone-rattling vibration, driving air pockets out and forcing soil particles to lock together like puzzle pieces. The operators work in relentless rhythm, advancing, reversing, overlapping each pass to ensure no weak spot survives. A layer of crushed stone, sometimes 18 inches thick, is spread across the prepared ground. This engineered aggregate will distribute the weight of 40-ton trucks across the soft earth below without cracking or settling. Water trucks prowl ahead of the rollers, spraying a fine mist that binds the stone and soil together. Too dry, and the particles won't compress. Too wet, and the foundation turns to mud. Field technicians monitor moisture levels obsessively, adjusting the spray in real time. This base layer may be built in multiple lifts. A coarse bottom layer of fist-sized stones creates the structural backbone. A finer top layer provides a smooth platform for the concrete above. Each layer is compacted separately, tested with nuclear density gauges to confirm it meets specifications. For 2 to 4 days, vibration sensors confirm the soil has reached maximum density. Laser surveying equipment verifies flatness to within millimeters per meter. Every pass of the roller builds toward a single goal, creating a foundation strong enough to support a horizontal skyscraper. When the compaction is complete, the roadbed sits silent and firm, ready to receive thousands of cubic meters of concrete. Miles from the construction site, an industrial batching plant roars to life. Dump trucks pour crushed stone, sand, and gravel into towering storage silos, segregated by size and type. The mixing process begins with surgical precision. Calibrated belt scales measure each ingredient to the exact gram. Crushed stone forms the structural skeleton. Fine sand fills gaps between larger particles. Too much sand weakens the concrete. Too much stone prevents flow through the paving machine. Measured aggregates drop into a feeder bucket. Next comes water, measured to the liter. Even a 5% variation in water content compromises strength by 30% or more. Chemical admixtures are injected through dedicated dosing systems. Superplasticizers make the mix flow without adding extra water. Accelerators speed curing in cold weather. Retarders slow hardening during hot pours. The ingredients converge in a twin-shaft mixer where counter-rotating blades churn materials into homogeneous slurry. Within 90 seconds, separate components become uniform, high-strength concrete. The finished product discharges into waiting ready-mix trucks, drums already spinning. The clock starts ticking. Concrete has a 90 to 120-minute working window before chemical reactions lock it into solid stone. The trucks accelerate toward the site, drums rotating continuously, racing against chemistry itself. At the construction site, ready-mix trucks queue in precise rotation. The slipform paver waits like a mechanical predator, hopper wide open, ready to consume thousands of tons of concrete without pause. Concrete pours out in thick gray streams as trucks discharge directly into the hopper. Any gap in flow means concrete sets in the wrong place, creating weak points that could crack under load years later. Inside the paver, an auger spreads the mix laterally while vibrating pans shake at high frequency, driving out trapped air and forcing concrete into every corner. The vibration is so intense workers standing nearby feel it through their boots. The slipform mold slides continuously forward, shaping wet concrete into its final profile in a single uninterrupted motion. Laser sensors and GPS guidance track elevation and alignment in real time, adjusting position with millimeter precision through curves and grade changes. As the paver advances, it automatically inserts steel dowel bars into fresh concrete. These 18-inch bars positioned at mid-depth transfer load between panels and prevent one edge from settling lower than the other. The paver leaves behind a seamless ribbon of concrete, flat to within 1/8 inch per 30 feet. A machine costing $120,000 to $300,000 replaces 50 laborers and delivers precision no human crew could match. On a good day, a single slipform paver lays 2 to 3 miles of highway. The concrete is down, but the engineering isn't finished. Within minutes, a curing compound sprayer coats the surface with a liquid membrane that seals in moisture. Concrete cures through a chemical reaction that continues for weeks. If the surface dries too quickly, micro cracks form that spread under traffic. Hours later, saw crews arrive with diamond blade cutters, cutting expansion joints at 12 to 20-foot intervals. These joints are intentional weak points that control where concrete cracks as it expands and contracts with temperature swings. Workers blast out concrete dust with compressed air, then pump polyurethane or silicone sealant into each joint, creating a waterproof barrier. Without this seal, water infiltrates through joints, seeping down to the base layer where it can freeze, expand, and destroy the road from beneath. Yellow paint marks lanes, orange cones block the entrance. For 7 days minimum, the roadway is off limits. The concrete must reach at least 85% of design strength before it can support vehicle loads. On day 7, site engineers return with core drilling rigs and compression testing equipment. Cylinders are extracted and crushed to verify strength. Only when every test passes does the road officially open, ready to carry millions of vehicles across the next half-century. Not every concrete road is born from million-dollar machines. In remote regions of Peru, where mountain roads connect isolated villages and budgets can't afford industrial pavers, the work falls to human hands and raw determination. Ready-mix trucks arrive with fresh concrete, but workers guide metal chutes to pour the mix directly onto the prepared roadbed. What happens next is a choreography of sweat and coordination that machines will never replicate. Dozens of workers move in synchronized rhythm, wielding shovels and rakes to spread concrete across the road width. There's no pause, no second chance. The material is already hardening. Handheld vibrators plunge into wet concrete, driving out air pockets while vibration numbs workers' hands after hours of continuous operation. Behind them, crew members follow with steel floats and trowels, smoothing the surface by eye and touch. Long wooden screed boards are dragged across the concrete by teams of 4 or 5 workers, leveling high spots and filling low areas. Without guided systems, precision depends entirely on the lead worker's judgment. It's exhausting, imprecise, and slow. A crew of 50 might complete 650 feet in a day, a distance a slipform paver covers in an hour. But in regions where roads mean the difference between isolation and connection, manual paving remains the only option. Halfway across the world, Chinese engineers faced a challenge that made even American highway construction look straightforward. They set out to build a road through the Taklamakan Desert, the Sea of Death, where summer temperatures soar past 70 degrees Celsius and sand dunes shift like ocean waves. The first enemy was the sand itself. Bulldozers deployed in formations of dozens, carving into dunes that rose 150 feet high, redistributing millions of tons to create a level surface. But leveling wasn't enough. The sand remained loose, unable to support construction machinery. Engineers injected water deep into the surface to bind grains together. Sprinkler systems stretched across the site until moisture penetrated several inches deep. Then 25-ton steel drums moved in, their constant rumble echoing across the dunes as each pass locked sand particles together. By the time the surface dried under the brutal desert sun, it had transformed into something hard enough to carry cranes and supply trucks. Workers spread a base layer of reddish soil over the stabilized sand, bulldozers pushing the earth flat to anchor the sand below and prevent shifting under heat or vibration. At the desert's edge, portable asphalt plants roared to life, heating stone, sand, and polymer-modified bitumen to 170 degrees Celsius. The mix had to stay hot. Drop below 140 degrees and it becomes too stiff to compact. Insulated tankers raced the cooling clock, delivering the scorching mixture nonstop to paving machines on site. The pavers spread asphalt in 2.5-inch layers, laying down a glowing black ribbon. Steel drum rollers followed immediately, compacting the material before it could cool. Heavy steel drums crushed the asphalt with pure weight, driving out air pockets. Final passes used rubber tire rollers, kneading the asphalt to seal microscopic gaps. Thermal sensors track surface temperature in real time. If readings dropped below 140 degrees Celsius, rolling stopped immediately to prevent cracking. Supervisors checked flatness with laser beams, allowing no more than 1/8 inch of deviation per 3 feet. As the desert wind swept across the finished surface, the asphalt hardened into a flawless black sheet, engineered to withstand temperature swings from -13 to +158 degrees Fahrenheit. Workers sprayed a protective seal coat, locking out moisture. By dusk, the newly paved highway gleamed under the sinking sun, a dark ribbon stretching across the golden sea of sand. After 4 grueling years, the 4-lane highway cutting across China's largest desert finally stood complete, a testament to human determination and technological mastery in the heart of the Sea of Death. From American slipform pavers, forging seamless concrete fortresses engineered to survive half a century, to Peruvian crews building roads by hand with nothing but raw human determination, to Chinese engineers conquering the Sea of Death by transforming shifting desert into permanent asphalt, concrete road construction stands as a monument to what human willpower can achieve when it refuses to accept nature's verdict. Every highway is a horizontal skyscraper, foundations compacted with the same force as 60-story towers, steel reinforcements positioned with surgical precision, layers engineered as unified systems that carry 40-ton rigs at 70 miles per hour without cracking under punishment that would destroy lesser construction in weeks. The next time you drive across smooth concrete, you're traveling on top of buried engineering that rivals any structure reaching into the sky. The difference is you never see the foundation, the reinforcement, the precision that keeps millions of vehicles moving safely across decades. Which feat impressed you most? America's automated machines laying miles of highway per day? The hand-built roads of Peru carved out by human endurance alone? Or China's conquest of the desert itself? Let us know in the comments. And if you want to keep uncovering the hidden engineering that holds the modern world together, subscribe and stay tuned for the next man-made marvels.